I think Altman has presented this at the start of our workshop. We actually have 6 different demonstrators within ProSurf. Here is a small chart which separates their functionality and their application fields into the different categories that we have here. So we have purely decorative features, we have optical effect features, we have tribological features, and we have also mechanically working surface features, and they all apply to different fields from medical or electronics to consumer products where they're used. So I'll just give a quick rundown of the demonstrators, and some of them you have seen, some of them you have not seen in detail. So I would like to use the main part of this presentation for the actual discussion, more discussion on the demonstrators and about our findings. So this one is the ProDeco demonstrator. You've heard a lot about this in the talk of Ilya. So basically it's a decorative type of structure where we generate a holographic effect by surface structuring, and main part in ProSurf was to increase the aspect ratio and thereby the range of color effects, let's say, in ProSurf, and we were quite successful in this, achieved a high replication fidelity and improved the adhesion of the surface pad of the surface layer to the mold. So before that we had, or NILT had problems with delamination of the mold, and they improved on that, and also had a look at the plastic replication. Staying in the optical regime of demonstrators, we have the ProSafety demonstrator. This is done by the nanofestool servo turning, where we actually inscribe a holographic feature into a product that is later used as, in this case, a surgical lens. So basically it's a part that has a high potential for being counterfeited, and this is a huge problem for the manufacturer. So you want some kind of identification measure within this part, and the hologram serves in this case as identification and batch tracking feature that we included. So we inscribe this into the mold insert. We've done a lot of work in redesigning the mold insert so we can actually set it up in our turning process, and then we can inscribe the hologram on the surface. And one other challenge was that, of course, the holographic feature needs to be consistent, not only on the mold, which we've done as metal mirrors in the past, but also on the replicated plastic parts. And there you have different aspects like shrinkage of the part, or varying thickness if you use this as a lens, as we have not done before. We have only used it in a mirror configuration. So in this case, it was a lens. That was another challenge that we had to face, and it worked quite well. In the end, we were able to replicate a hologram, not as good as we expected, but it works quite well, and it is identifiable as the image that we have put into this. The third demonstrator is ProPad, also a part optical, part mechanical, let's say, demonstrator. So it basically should be a car mirror that has some self-cleaning features, hydrophobic features, so that the raindrops that come onto the mirror surface just peel off and run off without sticking to the surface, and thereby cleaning the mirror and providing additional safety in this case. And we did a lot of tests on contact angles of this surface, on different types of structures that we applied, not only by fast tool servo machining, but also by milling operations, as you can see here, more groove type structures, and also hierarchical structures that we applied in this case. And we were able to improve the hydrophobic feature, and had to balance that with the transparency of this material as it is used as an optical component. So this was a major challenge in the ProPad demonstrator. You've heard quite a lot about the ProMati demonstrator, which is an optical connector where we try to introduce anti-reflective patterns for improving the coupling efficiency of these connectors. And their nil technology, Celloplast and Comscope, have done a great job in further developing the nano imprinting process in actually being able to generate these anti-reflective surface patterns, these nanostructures on the small lenslets that we need for this optical connector. So this was a quite challenging task, and you can see there are a lot of failures in generating these molds, and they finally succeeded in establishing a process where this is possible, at least on a planar surface, and we can work on from that. You just heard about the ProFlow demonstrator. So this is the one of the only demonstrator where the functional surface is not on the part itself, but on purely on the molding insert, and is used. The structure is used for reducing the mold wear and improving the flow efficiency. And you can see that this was quite successful. The process was stabilized so that more uniform sensor caps could be produced. The flow length overall of the molding process could be increased, and overall better parts were generated with the developments of ProSurf. The last demonstrator is a demonstrator which you have not heard that much of in the recent presentations. It is a purely mechanically working demonstrator, a roller for cleaning thin films. And there, the challenge is that you need to generate enough adhesion force for the small particles to be picked up by these cleaning rollers without having the film wrapping around the roller, which basically destroys the thin films. Films thicknesses are in a range of 50 to 25 micrometers, and they are quickly destroyed when wrapping around the roller. So here the focus was on finding and generating a surface pattern that supports the cleaning functionality without causing too much wrapping of the film. And Technic was quite successful in identifying the SSK parameter as one of the key parameters that changes between a new roller and a worn roller. And on this basis, we're able to establish a surface pattern which has a better wear behavior, is not that much affected by wear, and they were able to reduce the film thickness that they can clean without wrapping. They are able to remove more particles because the specific adhesion to the particles is larger, and they increased the lifetime of the rollers. So this was quite a successful demonstrator that they produced. And now I would like to maybe come to the remaining questions, or redirect new questions to the specific companies. And if you have any questions about the demonstrators, feel free to ask. We now have some time to talk.